It is shown in this video that mass-energy relationship E equals mc² is contained in Ampere's law. It's an expression of Ampere's law. It's inherent in it. One can persistently hear from the media that mass-energy relationship E equals mc² was derived by Einstein's relativity. But this is far from the truth. As is shown in another video, not only is Einstein's relativity internally contradictory and has no place in physics, but even if we decide to use only one aspect of it, the Lorentz transformations, as is done in part 10 of Einstein's 1905 paper, it is seen upon careful inspection of the integral presented there that mass-energy relationship E equals mc² hasn't been derived, despite the impression to the contrary. So let's first of all, before going further, let's recall some of the arguments regarding the fact that Einstein's relativity cannot derive E equals mc². Therefore, it would have been enough for Einstein to apply just the first postulate to the first set of equations in part 10 of his 1905 paper to represent them in the moving system and vice versa. However, then, a purely trivial solution would have been the result, and there would have been no discovery at all, as is really the case. In his desire to make a discovery at any rate, Einstein redundantly uses Lorentz transformations for such representation, and as a result ends up deriving two distinctly different expressions for the law of motion of one and the same body in one and the same system. Therefore, as already said, it is out of the question to suggest, as the media excessively submits, that Einstein's relativity derives mass-energy equation E equals mc², because the theory itself is invalid to begin with. It was shown in a previous video that the mass-energy relationship E equals mc² is in fact contained classically in the corrected expression of force, an expression corrected for the spatial effect in space of force, an effect which is being neglected in contemporary physics. Now this correction is mandated, is determined by the fact that the usually known D'Alembert's principle, which comes about from Newton's second law, and which states F minus ma times delta x equals 0 is non-physical if this delta x is a real non-zero displacement in space. Now, it is non-physical if delta x is non-zero, because if we write the Ampere principle in this way, this means that the work A to transport a body across a non-zero distance is 0, which is impossible. In reality, when a body, a free body, is transported by the application of a constant force upon it across a non-zero displacement delta x, work is done. There is no case in which transport of a body under the action of force can occur without doing work. Now, in fact, in today's physics, this delta x is usually considered as virtual displacement, delta x, and this work is considered to be some virtual work. But this is non-physical, and this sets physics into a direction of creating some irrational, quasi-scientific, or even outright non-scientific notions and concepts, such as some of the concepts of quantum mechanics, let alone Einstein's relativity, which has nothing in it. It has to be removed from physics altogether in its entirety. So if we have in mind the fact that delta x is a real non-zero displacement, then this D'Alembert's principle must be corrected. And the truth is that a non-zero displacement delta x under the action of a force of a free body results not only in this displacement, but also in a qualitative transformation in the form of energy. And we must write here, if we need to be in harmony with reality, if we want to be physical, we must write mv² over 2, which is the kinetic energy of a body. Motion of a body, of a free body, under the action of a force is always connected with change of energy in space. So from here, we may write, first of all, this force now will be the real force acting on the body, causing this change of kinetic energy. And of course, this delta x we may replace by x, because if we start from x0, because delta x will be some x minus 0. So from this expression, we get F real x equals max plus mv² over 2. And here we can apply this absolute equality that we talked about in another video, v² equals 2 times ax. And finally, when using this equality, we see that the second term, the first term after the equality sign, is the same as the second term. So it will be f real x equals mv² over 2 plus mv² over 2. And finally, so we have f real x, which is the work to transport this free body across a displacement x. And the work, to do this work, energy must be spent of the same amount. So this will be energy. Also, we should recall that because we're observing a case whereby acceleration is constant, and constant, and velocity is changing in time. This is velocity. This is velocity. This is time. Recall this graph from this other video. Acceleration is constant, dv dt, or delta v over delta t, where delta t is constant. This delta v over delta t is the acceleration, and we can easily understand that at high v's, as the time goes on, the velocity v becomes great, becomes very high, and in comparison, the acceleration, the constant acceleration, can be neglected. In other words, we can consider for high velocities, we can consider some constant velocity, c, in comparison to acceleration, and then we'll have mc². We can replace v by c. So as the motion progresses from this fundamental, most fundamental equation of mechanics, v² equals 2 times ax, which is a parabola. We see how as the motion progresses, as the x grows, gets higher and higher, the velocity almost gets into a plateau. So this is how mass-energy relationship exists in classical physics. And now we're going to show, to give another example of E equals mc² contained in classical physics, namely in Ampere's law. Observe Ampere's law in its differential form. Curl of magnetic field B equals μ0, which is the permeability of free space, times current density, plus μ0 times epsilon naught, which is the permittivity of free space, partial dE, which is the electric field, dt. And now we'll use the equality μ0 epsilon naught c², where c is the velocity of light, equal to 1. Thus we get c² curl of B equals 1 over epsilon naught times current density plus dE dt. Once we have Ampere's law in this form, we can proceed with a dimensional analysis. Meter squared over second squared. These are the dimensions of the speed of light. 1 over m, the dimension of nabla, and the dimension of magnetic field is kilogram over Coulomb second. For the right side of the equation, we have Newton meter squared over Coulomb squared. Times Coulomb over second times meter squared. Now these are the dimensions of current density, plus V volt over meter second. These are the dimensions of partial dE dt. Now, as an exercise, we can verify that the dimensions of the first and the second term after the equality are the same. Indeed, for the first term after the equality, we have some obvious cancellations here. So we get Newton over Coulomb second. But Newton over Coulomb is in fact volt over meter, which we can verify from the dimensions of volts, which are kilogram meter squared over second to the third ampere. Which is also kilogram meter squared over second times second times coulomb over second. Seconds cancel, and this is joule, which is also Newton meter. So what we have in the end is Newton meter over coulomb, or V volt over meter equals Newton over Coulomb. Indeed, Newton over Coulomb in the expression for the dimensions of the first term after the equality, Newton over Coulomb is volt over meter. And thus we see that the two terms after the equality are of the same dimensions. Now, this means that the whole quantity comprising the sum of these two terms has also the dimensions volt over meter second. Now we can verify also that the left side of the equation has the same dimensions as the right side of the equation, and we can rewrite here kilogram meter squared over second squared over coulomb over meter Now this is a joule, which is also Newton meter. Therefore we have Newton meter over Coulomb meter second. It's a second. This cancels. However, we saw that Newton over Coulomb is volt over meter. We have volt over meter times second. In this way, we see that the dimensions on the left side of the equation are the same as the dimensions on the right side of the equation. Now, having verified, just as an exercise, that the dimensions of all the terms in this differential form of Ampere's law are the same, we can write c squared 1 over meter for nabla, the dimensions of nabla, times kilogram over coulomb second These are the dimensions on the left side of the equation. And they equal Newton meter squared over Coulomb squared times, so this is the dimension, these are the dimensions of 1 over epsilon naught times the dimensions of the current density, which are Coulomb over second times meter squared. And now what we have here is we have these obvious cancellations again. Which gives us Newton over Coulomb second. These are the dimensions on the right side of the equation. And here we have c squared kilogram and these dimensions meter Coulomb second will be transferred on the other side of the equation. We'll have meter Coulomb second and now if we focus on the right side of the equation, we'll see that we have first Newton over Coulomb, which was volt over meter. We saw it 2 times already. So this is volt over meter. And Coulomb over second, this is amperes. Ampere. So in the end what we get is volt over meter times ampere times meter second. Meter cancels out. Volt ampere is in fact watt or joule per second. And so in the end we get joule over second times second, they cancel out, equal to joule. In other words, c squared kilogram equals joules. And now kilogram is the dimension of mass, m, and joule is the dimension of energy, E. Thus, finally, we get E equals m c². This is the mass-energy relationship inherent in Ampere's law. Notice now that the constant c², which is in the mass-energy relationship arrived at from Ampere's law, c², c, is the speed of light. However, the constant c in the mass-energy relationship E equals mc², stemming from the more general expression which was derived based on absolute truths and which accounts for the spatial effect of force neglected in contemporary physics. That constant c in general isn't the speed of light, the velocity of light anymore. Recall this expression: f real x equals max plus mv² over 2, which for high velocities turns into an expression containing this constant c. This is the constant, the practically constant velocity which the body acquires as the motion progresses, as the motion caused by the action of a constant force upon the free body, and which we saw in the parabola. v² equals 2 times ax. This is for different values of m. So this c, or c² here, which of course, because these two terms are equal due to this absolute equality, finally we get f real x equals mc², and this is the energy which is spent to do the work to transport the body across displacement x. So this c is already the velocity of the body, and the character of this relationship, E equals mc², of this relationship, tells us that there is no energy without matter. On the one hand. On the other hand, there is no transformation of mass into energy. In other words, treating mass as some sort of energy source for obtaining energy by transforming mass into energy. Here, what we see here is this E equals mc², is an expression, is a description of motion in the sense held in the view of Leibniz, that energy expresses motion, and indeed at these high velocities it is energy that is the expression of motion. Here Despite the fact that force acts on the free body, force loses meaning. Force has meaning at lower velocities, at the beginning of the application, and at these higher velocities, force has no meaning anymore. The motion of a body is expressed by its energy. This is what the character, this E equals mc² in this more general case, tells us.